In 6th grade, students find the volume of right rectangular prisms by filling it with fractional edge-length cubes. In order for students to be able to consider how many of these fractional edge-length cubes will fill a prism, and then how to use their findings to find the volume of that prism, students need experience with concrete manipulatives, including cubes of different sizes. Students' introduction to volume begins in 5th grade. Students determine volume by packing a right rectangular prism with unit cubes and using volume formulas. In 5th grade, the edge lengths of the prism are whole numbers only. In 6th grade, students extend their learning to find the volume of right rectangular prisms with fractional edge lengths. In addition, they consider how to pack these prisms with appropriate fractional edge length cubes. Students should be able to find the volume using these cubes by multiplying the number of cubes that fill a prism by the volume of one cube. In addition, they should be able to show that it is the same when using the formulas. In 7th grade, students should be able to find the volume of all right prisms, including rectangular and triangular prisms.
This is the way, if they had whole numbers in 5th grade, that they've learned it. Length times width times height. Here we're using fractional edge lengths. This is the volume of that prism. Now here's the difference that we are going to challenge our students with. Because we're asking them, well, what if we were to fill it up with, instead of 1 inch, 1 inch by 1 inch by 1 inch, we're now going to use what type of cubes? 1/4. And so what we need to do, what we're trying to figure out for each of these is how many what will fit into them. How many
1/4 parts are in that side length.
Right. So how many 1/4 are in here, how many 1/4 are in here, and how many 1/4 are in here?
So we need to decompose it.
So correct. We need to decompose these fractions to see how many 1/4 are in each of the side lengths. And so here we see that in 1/2 we have how many 1/4?
6.
And then in 1 we have 4. And then the last one? 15. So if we were to multiply each of those side lengths together, length times width times height, but we're doing it with 1/4, we end up with what?
360.
And that 360 represents what?
1/4 inch. How many 1/4 inch cubes fill up that solid?
Right. How many 1/4 inch cubes go into that rectangular prism? So we have 364 of them. Now, what is the volume of that 1/4 inch cube? 164. So if we were to calculate, because we want to compare, if we were to do it this way, we want to compare it to what they're used to doing. So if we were to do it this way, we would take how many cubes there are, 1/4 inch cubes, and we want to multiply that by its volume to figure out what the volume of the rectangular prism is. And so that's what we would do here, multiplying it, and we would get 360 over 64, and then we have 5 5/8 cubic inches as our volume. And showing this helps us to see that the volume is the same.
The volume lesson that follows was adapted from Georgia Framework 6th grade Unit 5 task, How Many Ways, and Volume in Cubes, and the CPOMS task, We Pack and Ship. Beginning with the context of shipping cupcakes, students use manipulatives to model boxing 24 regular cupcakes in a cube with 1 unit edge lengths, and then boxing 24 mini cupcakes in a half unit edge length cube, with the goal of developing strategies for decomposing fractional lengths, finding volume with the formula, and finding volume using the number of cubes in a prism.
Trying to find the
So what's the same?
way of how to make 24 into a cube. I just counted the blocks. I did the same for all the other sides. And I got 24.
The volume and cube lesson begins with whole unit cubes. Students are asked to create several prisms out of 24 cubes and find the volume. The goal of this task is for students to see how the number of cubes relates to the volume of the prism. What are you multiplying?
My width, and my height to get the volume.
Why do you think they all have the same volume?
Because they all have 24 units in it.
one of the small boxes is 1 cubical unit. So how many cubic units you put in one big box is your volume.
How did y'all find the volume of this one of the small boxes? How do you know it's one?
Because for every 24 unit volumes, you have 24 boxes in one big box. So if you take out one of the unit cubes, then you get your volume because it's one height, one length, and then whatever you get for like, if you had, like, let's say 10 again, if you had 10 of the small boxes and the large box, then the volume of the large box would be 10, since one of these equals 1 cubic unit.
The next day, a Would You Rather problem presented an accessible and engaging task for students to make connections between volume and unit conversions before moving into finding volume using fractional unit cubes. Working with half-unit cubes, students use a variety of strategies to find the dimensions of their prism built with 24 half-unit cubes. They will first find the volume by multiplying their dimensions, length times width times height. Then, building on the previous day's lesson, students find the volume of one of these half-unit cubes and discuss how the volume of one of these cubes multiplied by 24, the number of cubes, compares to their first method.
You can, every set of 2, it counts as 1. So, like, if you have 1/2, like, this counts as 1/2, and if you count it as 2, this is 1 whole. Then you keep going, another 2, then 3 and 4. It goes on. So every set of 2, it counts as 1.
1/8, because if you do 1/2 times 1/2 times 1/2, you get 1/8. That's the reason why the volume of the small box is 1/8. And you can find the volume of the large box by using the volume of the small boxes. You can add the volume of the small boxes to get the large box.
Okay. She said you could add all the volumes of the small boxes. Is there another way you could do that as well?
You can multiply.
Tell me what I'm multiplying.
You do 1/8 times 24 and get your answer.
Okay. What does the 1/8 represent?
The small box.
The small box. And what does the 24 represent?
The cupcakes.
Okay. How many there are?
Mm-hmm.
Okay.
Because 1 cubic unit equals 1/8. So I added in, both turned out to be 3 because the volume is 3 in cubic units. So both of them are the same. If you compare them, they're the same.
Moving through the CRA, Concrete Representational Abstract Instructional Approach, after the concrete phase of working with manipulatives, students use representations, such as a number line, to partition a fractional side length into unit fractions. Then, after determining the number of cubes in each dimension, they're able to multiply to find the number of fractional cubes that a prism will hold. Students begin to move into the abstract phase and have a variety of strategies. Some students find the volume of the prism and divide this volume by the volume of one of the fractional edge length cubes, while others use their understanding of equivalent fractions, convert the dimensions to a number of cubes.
So this will become, so the 1 1/2 will become 3 over 2, and then 5.
That represents the volume, and then you could, when we had did 1/4 times 1/4 times 1/4, we had got 1/60,880. Then we divided that by 8, so we got 360.
I knew there was 1 and 4 feet in each little box, So what I decided to do is I would write down how many little feet would fit in 3 3/4 feet, and that was 15. And I knew there was 3 feet for the width, and I did 15 times 3, and that equals 45. And for the height, 3 1/4 feet, it was 45 and 13, because 13 is the answer of how many bits of 3 1/4. And 14 and 45 times 13 is 685. 4/4. 4 feet is 4/4 times 3, you get 12. Like you're doing 3 times 4, you get 12. So it was like 12 over 4. So would it be 12 times 15?
I want you to think about which one would make sense.
Yeah.
To close the lesson, students connected the number of cubes to the volume of the prism. Some misconceptions occur when students have both mixed number and whole number edge lengths, as in the previous clip. Additionally, the variety of question structures that students may encounter warrant special attention to answering the questions asked. Items from the framework task, volume and cubes, and from GoFar, Georgia's online formative assessment resource, present tasks in which students may be asked to find the number of fractional edge length cubes, the size of the fractional edge length cube, the volume of the prism using the volume of the fractional edge length cube, and the volume of the prism using a formula, or even the volume given a diagram and the size of a cube.